By now, you know what it means by concave up and concave down. And I stressed the last time that to talk about concave up or down, it has to be an open interval. All because concavity is defined around differentiability, right? Geometrically, concave up means like that, and concave down means like that. Okay. Another way to check for concavity is if the second derivative is positive, it means concave up, because when the second derivative is positive, it means the first derivative is increasing. So when the first derivative is increasing, it means the gradient is increasing. When the gradient is increasing, it means it's concaving upwards. Some people ask me, why should it be, Now let's look at this one. When the graph concave upwards, the gradient is actually increasing because over here, very negative, lesser negative, 0, positive, more and more positive. So for graph that concave upwards, the gradient indeed increases. And likewise, when, do you remember what was written on the side? Let's see, Jethro, what was written on the side? There's a missing thing, fx. You see the bottom right on the screen? What? Let's see who are the attentive ones though. Jethro doesn't remember. Let's see. Mani, do you remember? What was written there? fx what? Right, I showed an example to illustrate to you that the converse is not true. Converse meaning to say, if you have concaving upwards, it does not necessarily imply this. You know what I mean? So the example I gave was x to the power of 4. And moving on from here, we want to look into this thing called inflection point. And we have understood that AKA means what? AKA means what? Also known as. Okay, let me check. Let's see. Gregory, can you tell us how do we locate inflection points? Shh.
First you find where the situation is from. You cannot find that equals that the situation is
After getting the values where the second derivative is 0, what else do you do?
Then you have to find where the point is greater than 0 or less than 0 and
this is a key step. Okay? It must change sign, otherwise it won't be. Gregory, can you give me an example where a function has second derivative 0 at a point, but it is not an inflection point? What example would you give? The same example will work, The same example shows you that if you try, at the point 0, right? The second derivative is indeed 0, but it's not an inflection point. In fact, it's a local minimum. And just now, Stephen didn't catch a fly. I saw him. Okay, so not sense, right? They're very clever. I also don't know why, They're very clever. Okay. Shall we try drawing this? While the rest of you try, let's invite. Okay, the next person on my list is Jairo. Could you march forward? Like it. Can the rest of you please try? You are given the f prime. You want to draw the graph of fx. Okay, Tingwei, obviously your book is not around. Yeah, you want to try this question? You're distracting the boys behind. Don't say. Right, you're in trouble. You get blue black, you know. You get blue black eyes. Are you all trying? Aditi, you obviously trying. Are you all trying to graph? Wow. It doesn't look right. Something's not let me go around the room to check that you're trying. You're not trying. Ethan, you can try it over. Can
I try?
On your paper, on the book.
I don't like it.
Okay, Aditi can go robot and collaborate with
Why is the light so here?
Why nobody tape it to the table? No tape. Any scotch tape or blue tack? Email. Who's the class rep now? Who? Viresh. And two boys. Why aren't the girl volunteering?
Because there's not enough for
1, 2, 3, 4, 5.
Because Chen Hui was class rep last year, then I think Yu Tong applying for senior council.
Oh.
That's the one, and then also the one.
Wen Yu then?
I
She will volunteer.
I think it was the one.
Okay lah.
Yes.
Because gradient changes from negative to positive, right? So which means this represents a minimum turning point in the
You might want to reach over there a bit.
Okay, nice drawing. Okay, before I forget, I better disconnect from the network first. Okay, like what Jared has done, he realized that this point needs to be a minimum point.
I don't understand.
Because see, in this graph here, it changes from negative to positive, right? Negative to positive, right? That tells me that in the original graph, it must be a minimum turning point. So maybe there's a minimum turning point somewhere there. Okay, maybe I draw it here. Okay, I draw it like that. There's minimum turning point like that. And then over here, right? Over here, it says the gradient is 0 in our original graph. On the left and right side is positive and positive. That tells me that it is actually an inflection point like this. Okay, tell me what this point is like in the original graph. Remember, turning point in the f prime is actually inflection point in the original graph. So which means if I may draw it nicely.
oh shit.
Nicely, I think it should look like this. This is an inflection point. And remember, inflection point, I typically like to use yellow. Why yellow?
Because it's hard to see.
Right, because hard to see. Of course, if you were to amplify that part of the graph, like what Jaira has done, if you try to emphasize it, sometimes it goes a bit wrong, you know. Like actually, the inflection point looks something like this. Here.
How do you draw an inflection point without this looking like it's just
The way to draw inflection point is you draw the dotted line first. Then you draw with respect to the dotted line.
But how do you draw the dotted line? Is it like
Guesstimation, aggravation. You know what I mean? Aggravation.
You usually just eyeball.
Yeah. So if I now want to draw this thing all over again, class, I will potentially actually draw this one first, you know. Draw this inflection point because it's harder to manage this part, you see. So I draw the inflection point first. Then I glide over, and then I again draw the inflection point here, and then maybe my graph may look like this. It doesn't matter whether it's a bit lower or is it higher. The vital points are all there. What color should I choose? Okay lah. This one. 1, 2, 3.
Draw below the axis. You won't know where. Why it's supposed to be below the axis?
You have an issue there? Let me know. Okay. Gary, you're looking at a book or looking at a handphone? I'm just curious. Oh, book. Okay. Okay, number 20. There are 3 graphs given there. You have to identify which one is the graph of fx, f prime, and f double prime. Okay, let's hear from someone again. The next person after Jared is Chimaya. What is your take on question 20? Which is f prime and f double prime? F prime is? So you say this is a f prime, is it?
I feel like this gets but
Can you see how many curves we have? What is the curves we have?
What is f? What's the function f? 3. And then you therefore mean to say this is f double prime, right? Let's check whether or not it works again.
Just see the more curves, right?
The more curvy one is normally the first graph, is it?
Yeah, because
I think in some sense, yes.
it does. It changes the thinking.
I think in some sense, yes. So let's check it. This is the graph of fx. This is the f prime again. This is f prime. So let's check whether the f prime actually matches up to what we expect to be. Okay, let's see again. Let's see. There is a zero gradient. True. It looks like there's a zero gradient here. It's an inflection point. It's true, no? Alright. Some other, I think the thing, this thing, a bit out of sync. I think maybe it should be here.
Yeah, the graph of one looks a bit.
Okay. And indeed, I think it's true. Let me double check again. This part of graph, right? This part of graph, the gradient is positive. It's true. This part of the graph, the gradient is actually negative. Is also captured here. It's true. And then this part of the graph, the gradient are all negative. Negative. It's true. Yeah. So I think it works. Okay. And then likewise, you can check now that the f double prime is graph number 1. Okay, by the same way of checking. And so therefore the answer is 3, 2, 1, is it? E. E for excellent. Oops. E for excellent. Okay, let's press on to do the last bit of chapter 2. Yep. In the other class, they told me this guy bought the result from someone. I'm not sure. Yeah, according to the class 504, I think this one he purchased the result from someone and named after himself. Yeah, I'm not sure how true it is. I'm not sure how true it is. Okay, what's important to note is in this L'Hopital's rule, you need to first and foremost identify the indeterminate form. Like in this example 21, right? If you were to put x as 0 into the numerator and then onto the denominator, you see it shows up. You have a 0 over 0. When that happens, that rule says I can evaluate this limit by differentiating the numerator tips. Right. And then now putting the value in and get 3. This is L'Hopital's rule. Cool, right?
Why does it work?
Yeah, I learned the proof as an undergrad, you know. I remember my professor, but to be honest with you, I cannot really recall that as a proof, to be honest with you. But I have to go and dig it out and read up again, you know. Yep. Maybe some of you can read it up and then can present in class. Only one hand is up, no? And that hand is Yu Tong's hand. She was doing this, so I thought her hand was up to volunteer. Okay. Once again, okay. Once again, you see the indeterminate form here. And therefore, you can apply the L'Hopital rule again. No. You must check each time you apply. If it doesn't work anymore, stop, kind of thing, no? If the indeterminate form persists, Jethro, you're right now. If it persists like this case, you could go on. Yeah, you could go on, if it persists.
What is 0 over 0?
Submit.
Oh, you're the kid. It's next to 1. The limit is wrong.
The limit is wrong, yeah, right.
It's not nothing.
Yeah.
You need a voice.
No one saw that.
So you keep going until you can. I don't understand why. Oh, you keep differentiating the time of the until it works. Okay.
Yeah. Someone in your class says, actually, Mr. Lim, I just need L'Hopital rule once for this question. He says, actually, from here, we are quite done.
Yeah, you can just multiply by x on both.
Right, you could stop there and then change gear to just factorization and cancellation. Yeah, right.
You just step L'Hopital all the way.
As long as the form persists, just go on.
So it has to be indeterminate.
Yeah, it must interpret.
What's the
Yeah. Right. If it works, it works very quickly. Likewise for this other one, when you do such question, right, you should at least demonstrate that this form exists first before you apply the rule. No? And in presentation, you might want to actually also say that when you apply the rule, you want to write by the side. L'Hopital.
Oh, we have to write.
Yes. Yep.
Wait, but do we have to keep writing that for every single time we...
If you are worried that people don't understand you, I would. And this will be equals to... Yep. Okay, my eyesight is very good, as you can see. Yeah. I told you the story, right? I don't have wear glasses because we're too poor to buy. But as I age, I begin to realize that my eyesight is deteriorating. Yeah. So, pardon me for that. If you don't write, is it? Misspell it, right? I think roughly we will actually take it. They will spell at hospital, right? They will spell at hospital.
Yeah, hospital.
I think that if it's marking a math paper, I'll probably be more forgiving. Because the numerator will be positive and the denominator will be a small negative number. Small.
And you can't apply it again because it's not.
Yeah, I can't apply again because it doesn't have the form.
So it's like a number over infinity.
As long as the numerator is finite and the denominator is very small, it has to be infinite.
So it's not easy.
No, I'm sorry. If it insists in D and E, you're not wrong, is it? But it's more informative to say this than to say this, is it? Okay, listen again. Question 22A. Question 22A. Chimaya, you didn't say much just now. Shh. Chimaya, for 22A, we want to use L'Hopital's rule. How? Jing, here, Jing. Okay. Is it because you can't see the screen tingling? I'm just curious. You can't see the screen. Okay, Chimaya is going to say something. We gotta use L'Hopital's rule. In his mind, he's thinking now, how to when it's like that. Because to use L'Hopital's rule, you need a fraction. Simi.
Wait, but what's stopping you from using x squared log x over x?
X squared.
X squared log x over x.
And okay, maybe it's easier, no? Kailash, the one you introduced might work, but this might be more straightforward. Okay, Chimaya, press on and tell me what do I do next. Why is it I can do that? Because it has the indeterminate form. What is the indeterminate form? To be exact, right, is negative infinity. Simi.
Oh, but it's 0 plus. But if it was 0, then you couldn't do that, right?
You can't, yeah. So this becomes, gosh. I think when I touch the screen somewhere, there is, okay. And it gives you limit. And this could be, I made a mistake again.
Once you solve it around, it's x over 1 over log x.
Oh,
Just solve it around.
yeah, just flip it around and get minus x.
Okay, fine.
Okay, you want to try the next question or everyone just hands on the next question? I'm trying to give you a bit of time to try first. Oops. Okay, can you try the part B while I actually do a recovery because it died. It died. Okay. Okay. For this question, right? For this question, we have to perhaps combine them first and foremost as a single fraction. After combining them as a single fraction,
It's not on the screen though.
what is it?
It's not on the screen. You can't see the screen.
Oops. Yeah, combine them as a single fraction. Then once I've done so, right, this becomes a 0/0 form, and now we are ready to actually apply the L'Hopital's rule. Again, the indeterminate form persists. So you can do once more. Yeah, not quotient rule, no. Just differentiate the top and bottom separately. Just differentiate them separately, no. And this gives you 0/. What about it? Oh yeah. Thank you for that. I'll roll back. Remind me again. I'll roll back. Okay. The constant. Okay. The same gradient thinking. Two functions, the same gradient throughout. Okay. I'll roll back later on. Thanks for the reminder. Okay. Aditi, before I roll back, can you tell me how do you think we ought to do 23? Let's see if
logically you get like x plus and then you can take out the non continuous function, right?
maybe.
Oh.
有没有
Oh, it's
Do you know that e to the ln of star is not the moon, it's not the sun, it's still right. Do you know now?
now I know.
Okay, James, what do I do after this? Because exponential is a continuous function, we can actually do it as like that, you know. And And by the earlier example, okay, Kailash, do you know this result?
Yes.
So I'm rewriting this fella as this line.
I get that part. I don't get the part where the heat just comes out and then goes on.
You can move that.
Since e power x do you remember the limit as x goes towards a function towards a, and this function is continuous? It's the same as if the function f is continuous. Okay, Rayson, since you're awake now, I'd like to pose a challenge to Rayson. Rayson, go to the board. Go to the board first, I'll tell you what to do. Just go to the board first.
He's wearing his shoes.
Okay, wearing your shoes. Okay, never mind, in that case, never mind. I get James. James, go to the board. March to the board. Okay, James, march to the board.
When you walk, right?
Okay, James, I would like you to actually sketch for me the graph of x ln x. You can erase all whatever you have on the board. Sketch sketch the graph of x ln x. X ln x. Tomorrow we are going to start off with tutorial 2, no?
Like that?
We are going to start tutorial 2 tomorrow.
Okay.
Still become like this.
Yeah. Let's just, no, we're going to start off with this assignment. We're going to start with tutorial 2 tomorrow.
I think there's something like oh yeah,
Try it.
I think actually I should do something that's like this.
Isn't that long? Then you doesn't write it.
If you make too much noise, James can't think, you know.
Okay guys, keep quiet.
Don't worry, I send you a help. I'll send Kaita. Kaita, two of you can collaborate to draw x ln x. And for the rest of you, can try drawing. I'll go down to check, you know. I'd like to see your x ln x graph on your paper. Well, not bad, quite close, but give me more details. Oops.
Wait, no.
You're not going to use the GC of handphone, right? That's small, is it?
No, it's my brain.
I'd like to see people trying to draw.
You see, I'm correct.
They use that small one.
Yeah, that's what I did. That's what I did. Yeah, I'm What is this? Is this like here? Why not this?
Yep. You draw first, I take a look.
What is this? You cannot just do that. I got the rough shape.
Yeah, you're right. He's right. This graph has been drawn like this. He's right.
Zero is an open circle.
，You must put unshaded circle there. James, you see? At x equals 0, the function is undefined actually. Okay. Okay, thanks James. Good. Yep. It comes in very, very steeply at origin. Okay, comes in very steeply. By the way, the 0.368 right is actually 1 over e. The number right is actually 1 over e. How do I come up with this graph, right? So first and foremost, I'll do this now. Whenever I draw a graph, firstly is I try to find the intercepts. I will ask this question no. When x is 0, to start with, x cannot be 0. So I leave it aside first. Can y be 0? Yes. When y is 0, it happens when x is 1. Okay? So I know there's a intercept here. Secondly, I look for stationary points. And if you perform the usual calculation, you will be able to establish this as a minimum turning point. So I'll get this marking on the graph. And then, by what we did just now, what did we do? We did this just now, remember? We did this.
What do you have?
We want to know how the graph behaves as it approaches 0. So therefore, I know that the graph will go very close to 0 as x goes with 0. But this point is excluded because when x is exactly 0, the function is undefined. Let me know. So after that, after getting the red markings, I will need the next fourth thing. Can you guess what's the next fourth thing? Start with C. What's the next? Whoa! You need the courage to join up them in a smooth curve.
Wow.
Okay, don't need this, okay? You all don't need this, you are very confident. You see, after getting all the markings, right? You'll be doing this, to do or not to do. To do or not to do. So you just gather the courage they have and join them up nicely as a curve.
To do or not to do? Is that even a question?
Have you come across instances in life where you always think no, to do or not to do? Do you have this count?
The hesitation.
Hesitation, that's right. Do you have this? We always come across situations like this in life. To do or not to do. Okay.
Procrastination.
Procrastination.
Procrastination of homework.
Okay, let's move on to this. In the case where the limit as x goes to infinity, what is important is, for example, if you have a statement that's like this. I want to ask you, geometrically, how will the graph be like? And you have already learned, when that happens, it is actually going to be a this is 5.
No, this is less than this.
Okay. Now, many times, right? When you talk about asymptotes, you all have learned very well. If I just ask any of you, like for example, I ask Lawrence, what are asymptotes? You will say briefly that asymptotes are. Shh. Lawrence, please. What are asymptotes? And he says they are asymptotes. He knows, and he knows I know, and I know that he knows. Okay, right. Okay. It is something that the graph approaches, but never reaches. So when I say this, right, then very quickly, student says, Mr. Lim, I think you made mistake. He says, like that how? So is this line y equal to phi an asymptote? And we say it's an asymptote, why is it? Why do they meet? And the answer is such asymptotes only works. Okay.
Unless it's Fy.
How when? What? Huh? What?
Yes.
Yes.
I was asking the class, how come it is still an asymptote even though it cuts? Because this kind of asymptote only works for large variable x. I mean, only when x is very, very large. Yeah, when x, so when x is not that large, it's okay to cut. And that gives student a peace of mind. You know what I mean? Likewise, you understand now that when that happens, you also have another horizontal asymptote on the other end. Potentially, it looks like this. And your asymptote could either be coming from the top or bottom here, but it is like that, it's gliding towards. Ivan, all asymptotes must be either vertical line or horizontal line. True or false? Shh. What else can it be? So he said got horizontal, got oblique, and got vertical. That is all. Ivan, true or false? Only horizontal, vertical, and oblique. That's all right now. Okay, Ivan judged from my tone, and Ivan wants to say no. He said there's more than just this three. Okay, Ivan, please. Another example that is not horizontal, not vertical, and not oblique. Simi. What did he say?
The one along the z-axis.
He said it makes an asymptote from scratch using starch button.
Class, lo and behold, asymptote can also be curvilinear. This graph looks like this. Asymptote can also be curvilinear. It not be vertical, horizontal, and this is a curvilinear asymptote. Curve. Curvy and okay, curvy. No, it's together. Okay, I hope it's spelled correctly. I'm not sure they got R now. I thought maybe there's an R here, no? I think there's R here. Curvilinear. I think it's Curbil. I'm not sure whether got another R or not. Okay, my spelling might be wrong. Curvilinear. So I'm trying to tell you that it can be all shapes and form, you know, asymptotes. It's not confined to lines. Right, it tends towards but never touching.
It can be like playhouse.
Can be what?
Like you have a plane.
Okay, if it's three-dimensional, it's true. asymptotes are like touch me not.
There's a function and another function.
Yeah. Okay. For this equation, the whole world knows. The whole world knows. And we all know that they have asymptotes. Right? These are the asymptotes of this graph 1 over x. The whole world knows. For this example 25, right? Some people say, Mr. Lim, I don't need anything, no. And they cheated. They say, when x goes towards infinity, these two are negligible. They say, if you present like this in the exam, I want you to know, you get 0, no.
What?
You must painstakingly do this, no. 24 is it? 24 is this, bro. This one.
25 is 0, but I'm saying.
So then if x squared approaches infinity, how can you disregard x?
Simi.
3 is not significant.
Okay. You're talking which one? Yeah, so you do this, right? You do this. 3 over x squared, right?
Just sit.
No, I was saying that the cheater way is not valid, you know.
The shortcut.
The cheater way means because when x is large,
X.
this thing is small compared to this, is it?
But
Like 1,000 compared to 1,000,000. 1,000 very small. 1,000,000 compared with millions, you know.
Why can't you use a shortcut? It makes sense.
Okay, if you use shortcut, you will fall over the cliff. When I was driving in the US on Route 101, is coastal driving, you know. If you're not careful, if you go off the cliff, you land down in the ocean, you know. Yeah, really, you know. Legit, you know, legit.
4 decades maximum.
But then it makes sense. I think that's something that you can't use a shortcut.
In the tutorial, I'll show an example.
Oh, not as an example, shortcut.
The shortcut doesn't work in the example, in the tutorial. Now class, lo and behold, because you already got to know L'Hopital, you have just befriended L'Hopital earlier, you could actually alternatively do it this way because he is there. Right behind you. And likewise, you could actually do the same for hospital. They use the L'Hopital. Well, this is 2/3 class, this is actually 0. No? How one? What is it? Okay, Ashad, speak up. Okay, I still owe you that part, you know, the thinking, the difference of two functions with the same gradient, you know. Maybe I do it another time, because I just don't want to hold people back.
You just use the shortcut after
This one, right? This one, I will advocate the use of L'Hopital. Yeah, it looks the same, you know. Yeah, right? The examples are lame, right?
I also feel that one, but yeah, that one is the same.
When the denominator gets too large and the numerator is some finite value, Stephen, what happened?
Sorry?
Just say 0.
0.
Right, you're right.
Insane.
You should actually present nicely by saying that the indeterminate form is there before you use the L'Hopital, and when you use it, you want to qualify it, no? You want to qualify it, no?
So then why did they put the plus infinity there?
See me. Question boy. This one is it?
Yeah.
Yeah, you're right. No, redundant, no, Aditi. Yeah, we will remove that next time. This one is the same that is the earlier question, you know.
Mr. Lim, you always have to quote long.
It's good to say, so that we know that you know. You know what I mean? It is always good that you say right there, write down there's an indeterminate form.
Mr. Lim, plus.
Aditi was objecting to writing plus there, and I respected her point of view, and that's why I remove it, you know. I made mistake, you know. That means no. 2x. And then you do it one more time, you know. Okay, you do it one more time. Right. Okay. I shan't hold you back any longer. It's a lunch break, is it? Or what? Okay.
Guys, the Wednesdays are very short, but
Okay, go. Class is dismissed.